Welcome back to class 6 series on my channel Mathify with Minakshi. Have you ever noticed that numbers follow beautiful patterns? Some numbers keep adding, some multiply, and some grow in a very special way. So today we are going to explore amazing number sequences from chapter number 1, Patterns in Mathematics. But first you should know what is number sequence. A number sequence is simply a list of numbers arranged in a special order following a particular rule. Now, let's look at different examples one by one. First sequence 1 1 1 1, basically it all ones. As you can see, that number stays the same, it never changes. You can say like it's a constant series where the number is fixed. Second, 1 2 3 4 5 6 7. So what is this sequence? You know that we are adding 1 every time. Yes. So this sequence is simply counting numbers because we are starting with 1 and we are adding 1 to get the next number. You can say natural numbers or you can say counting numbers. Next sequence 1 3 5 7 9. You realize this thing that we are adding 2. Yes, in every step we are adding 2, but here we are starting with 1. So whenever you start with 1 and you add 2 to get the next number, you always get all the numbers as odd numbers because they cannot be divided equally in two groups. Yes, so these are odd numbers. We are always adding 2. Let's move to next sequence. Here we are starting with 2 and then we are adding 2 to get the next number. So you can see the series is 2, 4, 6, 8, 10, 12, 14 and so on. That means this is sequence of even numbers because even numbers can be divided equally into two groups. So here we can divide them in two groups like 2, 1, 1, 4, 2 2 6 3 3. So we can divide equally and that's why they are known as even numbers, or you can say that all numbers are divisible by 2. Let's move to next sequence 1 3 6 10 15 21 28. Here you observe something. Yes, in first we are adding 2 and then we are adding 3, then you are adding 4. So what we are doing here, we are adding counting numbers to get the next number. So this sequence is known as triangular numbers. Here we are adding up counting numbers. Like if you will write the counting numbers like this, and so on. So in first step we are just writing 1. In second step we are adding 1 and 2, that's 3. In third we are adding 1 plus 2 plus 3, that is 6. In fourth we are adding 1 plus 2 plus 3 plus 4 and so on. So this is also known as adding up counting numbers. Adding up counting numbers. Okay, let's move to next sequence. 1, 4, 9, 16, 25, 36, 49. What is special for this sequence? If you realize carefully that here how we get 1, 1 into 1. For 4, 2 into 2. For 9, 3 into 3. For 16, 4 into 4. That means if we multiply the number with itself, we'll get the number. So here we'll multiply 5 into 5 and then 6 into 6, 7 into 7 and so on. So when we multiply the number by itself, that is known as square numbers. Here we are multiplying the number with itself. So I'm writing the rules here. Multiplying the number by itself. Next, 1, 8, 27, 64, 125, 216. Yes, here we are multiplying the number 3 times. 1 into 1 into 1. Here 2 into 2 into 2. And then 3 into 3 into 3. As you can see here, 3 into 3 is 9. 9 into 3, 27. Then 4 into 4, 16. 16 into 4, 64. Then 5 into 5, 25. 25 into 5, 125. And then 6 into 6, 36. And 36 into 6, 216. So when we multiply the number with itself 3 times, then we'll get this series. And that is also known as cubes. So this is the rule when we multiply the number 3 times again with itself. Now, next series, Virhanka numbers. This series, if you will observe carefully, first we have 1, then we have 2, next is 3, next is 5. So if I will say that if I can add numbers here, I will add 1, then I will add 1, then I will add 2, then I will add 3. So no, we are not getting sequence here. So just observe here carefully that what you will do here. Here you will add previous two numbers to get the new number. If you will add 1 and 2, what you will get? 3. If you will add 2 and 3, what you will get? 5. If you will add 3 and 5, you will get 8. If you will add 5 and 8, you will get 13. If you will add 8 and 13, you will get 21. This is also known as Fibonacci series, where what we have to do, we have to add previous two numbers to get the next number. And because here we have to add the previous two numbers to get the next number, that's why here first two numbers should be fixed. Then only we can add the previous two numbers to get the next number. That's why here first two numbers is always fixed, that is 1 and 2. So you will start from 1, 2, and then you will apply this rule that to get the next number you have to add the previous two numbers. Now let's move to next sequence. Again I will change color for that. Okay, next is 1, 2, 4, 8, 16. If you will see here carefully what we are doing, we are simply multiplying the previous number with 2 to get the new number. See here carefully. 4 into 2, 8, 8 into 2, 16, 16 into 2, 32, and 32 into 2, 64. So, series where we simply multiply the previous number by 2 to get the new number, we say powers of 2. Why? Because 1 can be written as 2 raised to the power 0, 2 can be written as 2 raised to the power 1, 4 can be written as 2 raised to the power 2, 8 can be written as 2 raised to the power 3, 16 can be written as 2 raised to the power 4, and so on, 32, 2 raised to the power 5. So this is known as powers of 2 because we are simply increasing the power of 2. Now, you should know the meaning of this also, that when we say 2 raised to the power any number like 2 raised to the power 3, that means you will repeat this number how many times? Whatever is written in power. That means I will multiply 2 3 times. If I will say 2 raised to the power 5, that means I will multiply 2 5 times. So base you have to write how many times. For that you have to see exponent. That's power. I think now the concept is clear to you. And when we say 2 raised to the power 0, now you know that when we increase the power, that means multiply. Like 2 raised to the power 1, then 2, we multiply by 2. 2 raised to the power 3, we again multiply by 2. But when we have to go back, like we are going back, 2 raised to the power 2 to 2 raised to the power 1. In that case, we are dividing. Just see, 4 divided by 2 is 2. So now if you want to go back one more step, like from 2 to raised to the power 1, you want to go to 2 raised to the power 0, again you will divide by 2. So that's why it's 1. 2 divided by 2 is 1. You can see here 32 divided by 2, 16. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. So for one more step, if you will go up, you will get 2 divided by 2, and that is 1. Okay, let's move to the next sequence, that is 1, 3, 9, 27, 81, 243 and 729. Here what we are doing? Again, we are just multiplying the previous number by 3 to get the next number. And when we start with 1, this one is very important. When we start with 1 and we are multiplying with a fixed number, then only you can say that it's a power of that number. Okay. So into 3, again 81 into 3 is 243, again into 3 is 729. Now, Let's write the rule for both. It's multiply by 2 each time to get the next number. You can also write multiply by 2 with previous number to get the new number. Here multiply by 3. So if it's power of 4, you will multiply by 4. Power of 5, you will multiply by 5. But here you have to be careful for one thing. That first number should be 1. Then only you can say powers of that number. Because if you start with 5 and you will say 5 into 2 is 10. 10 into 2 is 20. That again you are multiplying by 2, but you can't say powers of 2. There you will write just the multiplication by 2. Powers of 2 we can say only when you will take the prime factorization of that number, and you will get only 2's. Similarly, if you take the prime factorization of that number, you will get only 3's. Now I want to tell you one more thing. Even if a sequence does not start from the very first number, you can still identify it correctly. For example, in the sequence of odd numbers, if I will say that instead of starting from 1, someone write 5, 7, 9, 11, 13, and so on. Even then you can clearly recognize that it is a sequence of odd numbers. This means that if the starting 1, 2 or 3 numbers are skipped, but the pattern continues in the same way, the name of the sequence remains the same. However, numbers cannot be skipped in between the sequence. That means pattern must continue properly. Example, if I will say the sequence is 5, 7, but then I skipped 9 and I will say 11, 13 and so on. In this case, you can't say that it's a sequence of odd numbers, because in sequence of odd numbers, the gap is always 2. Now, let's move to figure it out based on these number sequences. So, it's on page number 3 of your book. Can you recognize the pattern in each of the sequences in table 1? That we have already done. I've already explained all the sequences to you. So it's already done. Now let's move to second question. Rewrite each sequence of table 1 in your notebook along with the next three numbers. So here we have to write next three numbers in each sequence. After a sequence, write what's the rule. So here we have to do two things. We have to write next three numbers and rule for that. So let's see that table again. So let's write next three numbers. As you know, that first sequence is all one. So I will write rule here that here numbers stays the same. The number stays the same, although you can also say that's a constant, or you can simply say it's all ones. That's already written. So I'm writing here that number stays the same. It never changes. That's a constant sequence. You can also say it's a constant sequence. So what will the next three numbers? If someone say what will be the next three numbers, you will simply say 1, 1, 1. Yes, let's move to second. It's the sequences of counting numbers. Here the rule you can say that add 1 every time, because we're simply adding 1 to get the next number. So if you will say what will the next three numbers, it will be 8, 9 and 10. Let's move to third. It's sequences of odd numbers. We can say that we have to add 2 each time. But important thing is starting from 1. Starting from 1. Here it's from 1, so I'm writing starting from 1. All numbers are odd. So what will the next three numbers? You will add 2 with 13, you will get 15. Then 15 plus 2, 17. And 17 plus 2, 19. Fourth is even numbers. Again, you will write add 2 each time. Or you can say add 2 to the previous number to get the next number. But again, here we are starting from 2. In this sequence, we are starting from 2. So I'm writing the rule for that only. So what will the next three numbers? You will add 2 with 14, you will get 16. Then 16 plus 2, 18. And 18 plus 2, 20. Now let's move to fifth sequence, triangular numbers. So for here we have two rules. First, that you can add up counting numbers. Like first number is 1, then 1 plus 2, then 1 plus 2 plus 3, then 1 plus 2 plus 3 plus 4 and so on. And second rule is that you can simply add counting number with the previous number. Like if the first number is 1, you can simply add 2 to get the next number. Then you will add 3, then you will add 4, then you will add 5, then you will add 6, and then you will add 7 and so on. So next three numbers will be that you will add 8, then you will add 9, and then you will add 10. So that means 36, then 36 plus 9, 45, and then 45 plus 10, 55. So rule is adding current position number to the previous number. That means if you have to see the position of 3, that's second position, so you will add 2 to get the next number. If you will see the position of 15, that is fifth, so you will add 5 to get the next number, and so on. One more thing, if you want to find directly the nth number in triangular numbers, what you can do, I'm telling you one formula, so you can simply put the value here like n into n plus 1 by 2. So if someone will say that you have to find the eighth number in triangular number series, you will simply put 8 as n and you will get the answer. And why we write this formula? Because this formula is for sum of first n numbers. And as you can see that triangular numbers also is adding up counting numbers. That is sum of first n numbers. Now let's move to next sequence. That's squares. So I've already written the rule for square, that's multiply the number by itself. So now we have to write next three numbers. That means 8 into 8, 9 into 9, and 10 into 10. So what is 8 into 8? It's 64. Then 9 into 9, 81, and 10 into 10, 100. Rule is multiply the number by itself. Next sequence is cube. Again, the rule we have already discussed. Multiply the number by itself 3 times. So here, what will be your next three numbers? 7 into 7 into 7, that is 343. 8 into 8 into 8, that is 512, and 9 into 9 into 9, that is 729. Now let's move to next sequence that's important, that's Virahanka numbers. You can also say Fibonacci series, where how we can get the next number by simply adding the previous two numbers. So if you will add previous two numbers, you will get next two number. So what is 13 plus 21? You can say 34. What is 21 plus 34? That is 55. And what is 34 plus 55? That is 89. So these are the next three numbers. Now let's move to second last sequence, that's power of 2. So here the rule is multiply by 2 each time. But as I told you, that start from 1. Now what are the next three numbers? 64 into 2, that is 128. Then 128 into 2, that is 256, and then 256 into 2, that's 512. Now let's move to last sequence, powers of 3. Rule is multiply by 3 each time. So we'll multiply by 3 to get the next number. So 729 into 3, that is 2187. Now 2187 into 3, that is 6561, and then 6561 into 3, and that is 19683. So that's it. We are done with the figure it out. Now let's move to pictorial representation of these sequences. So first, all ones. So here you can see that we have to simply draw the one circle because it's all ones. For counting numbers, we are adding the circles. Like first it was 1, then 2, then 3, then 4, then 5. So next will be 6. Yes, here it's same 1. For odd numbers is as you I have discussed that in odd numbers we can't divide them equally in two groups. As you can see, here we have a pair, but here it's single. Here we have pair, then it's single. Then again we have three pairs, and then one is single. Then we have four pairs, and one is single. So again, next step we have five pairs, and one is single, and that's 11. You have to write the number too. Yes, let's move to next sequence. Here you know that we can divide them equally in pairs, like one pair, then two pair, then three pairs, then four pairs, then five pairs. So next will be six pairs. One, two, three, four, five, six. And number will be 12. Yes, easy. Let's move to next. Now triangular numbers. In triangular numbers, as you know that we are simply adding up numbers like 1, then 1 plus 2, then 1 plus 2 plus 3, then 1 plus 2 plus 3 plus 4, then 1 plus 2 plus 3 plus 4 plus 5. So next will be 1 plus 2, then plus 3, then plus 4, then plus 5, then we'll add one more line here, plus 6. Just see where I'm drawing the circles in between the two circles. So that is, what is the next number? 15 plus 6. That's 21. And at last, it looks like triangle. If you will see carefully, no need to draw. I'm just telling you this thing. That's why it's also known as triangular numbers. Now, let's move to next, squares. As the word is square, so at last the figure looks like square. If you'll see carefully, it look like square at last, and so on. Now, here it's 1, then 4. As I told you, 2 into 2. So you can see here also we have two circles, then here also we have two circles. 9 is 3 into 3. So here also we have three circles, and then breadth-wise also three circles. Here we have four circles, then we have four circles. Next we have five circles, and there also five circles. So for next step, what I will do, I will repeat six circles six times. That means 1, 2, 3, 4, 5, 6. And I have to repeat this six times. 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And last line 1, 2, 3, 4, 5, 6. So at last it looks like square. You can write 36. That's the next step. And now cubes. For cubes, you will see carefully it's 1, then 8. That means first is 1 into 1 into 1. And second is 2 into 2 into 2. So here we are repeating this 2 into 2 is square. But again, one more time we have 2 because we are extending it this way also. So here also it's 3, 1 into 2 into 3, then 3, 1 into 2 into 3, and then again here we have 3, 1 into 2 into 3. So 3 into 3 into 3. Here also we have 1, 2, 3, 4, then 1, 2, 3, 4, and this side also we have 4, 1, 2, 3, 4. So you can say 4 into 4 into 4. Here again 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and this will also 5, 1, 2, 3, 4, 5. That means 5 into 5 into 5. So next will be 6 into 6 into 6. You can say 216. So I will draw that. First you will draw one cube. In exam you will draw properly with the help of ruler. I'm just drawing that roughly just to explain that to you. Now I will draw, just see the lines here. 1, 2, 3, 4. 4 vertical and 4 horizontal. So you will increase one line. Now you will draw 5. 2, 3, 4, 5. So let's draw that. 1, 2, 3, 4, and 5. Here also you will draw 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Simply you will do now. Here also you will draw 5 lines. Just extend these lines. 2, 3, 4, 5. Little bit slant. Then here also you'll draw 5 lines. 1, 2, 3, 4, and 5. Here also you will draw 5 lines. First I will extend these lines. 1, 2, 3, 4, and 5. And now you will extend these lines also. It's 1, 2, 3, 4, 5. I will just correct this figure a little bit from here, like this. Okay, so it's 216. As you can see, 6 from here. 1, 2, 3, 4, 5, 6. 6 from here. 1, 2, 3, 4, 5, 6. And 6 from here. 1, 2, 3, 4, 5, 6. Now let's move to figure it out. So copy the pictorial representation of the number sequences in your notebook and draw the next picture for each sequence. That we have already done. Let's move to second question. Why are 1, 3, 6, 10, 15 are called triangular numbers? I will show you that. They're saying this one. Why these are known as triangular numbers? As you can see that these numbers can be arranged in the shape of a triangle. That's why they are known as triangular numbers. Similarly for square, these numbers, when you will draw this figure, at last it look like square. That's why they are known as square numbers. And similarly for cube, you can say at last, when we draw this figure, it looks like cube. So you will write that answer here, that these numbers, first I'm writing for 1, 3, 6, 10, 15, can be arranged in the shape of a triangle. And that's why they're known as triangular numbers. For second, for square numbers, you will write these numbers form a perfect square shape, and that's why they are known as square numbers. For cubes, again, you will write these numbers form a perfect cube shape, and that's why it's a cube numbers. Yes. Now let's move to third question. You will have noticed that 36 is both. They are saying 36 is both a triangular number as well as a square number. As 36 can be arranged perfectly both in a triangle and in a square shape. So make pictures in your notebook illustrating this. So I will draw 36. Let me see that we have drawn this before, so I will not draw that again. Yes, you can see that here we have already drawn that 36 for square. Let's draw 36 for triangular numbers. After 21, what will come? You will add 7, you will get 28, and then when you will add 8, you will get 36. That means for 36, we have to draw 8 lines. 1 plus 2 plus 3 up to 8. So I will draw here for that for you. 1, then next 2, then 3, then 4, then 5, then 6, then 7, and then last 8. That's for 36. So this is for 36 as a triangular number, and here 36 as square. So this is your answer number 3. But here they write that this shows that the same number can be represented differently and play different roles depending on the context. Try representing some other numbers pictorial in a different ways. So I'm giving you one note that if you will take any number raised to the power 6, any number, then that can always be represented as squares and cubes. So just take any number. Like if you will take 2 raised to the power 6. What is 2 raised to the power 6? That means you're multiplying 2 6 times. So you'll get 64. That means 64 can be represented in both the ways. It's a square number also and it's a cube number also. Similarly, 3 raised to the power 6. That is 729. Again, it can be represented as square and cube. So it's very easy way to learn. Just take any number raised to the power 6. Why is it so? Because we can break this as 6 as 2 into 3. That means we can write this as either 2 square cube or 2 cube square. That means either 4 raised to the power 3, that's a cube number, or 8 raised to the power 2. That's a square number. So I will write this now. 64 I'm writing in two ways, in square and cube. So for square, you will draw 8. 1, 2, 3, 4, 5, 6, 7, 8. You will repeat this 8 times. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 2 we've already done, so now we're doing 6, 6, 6. So this is, you can say 8 square. Yes, 8 and 8, it's a square. Now let's move to next. I'm drawing now cube representation. You can see 64 can also be written as I discussed, 4 cube. So you will draw cube first. Now, if it's a 4 cube, you will draw 3 lines, 3 vertical, 3 horizontal, because then you will get 4 partition like this. Similarly, you will extend this. You will use ruler for that. I'm just drawing with a free hand. So your gap should be equal. And here again, now you will extend these lines. So this will give you cube. We'll just correct this one. Yes, it's square. You can write this. It's a square and it's cube. Let's move to next question. What would you call the following sequence of numbers? Now, this is hexagonal numbers. This was not there in that table. So I will explain that. What is hexagonal numbers? If you will see carefully, at last it look like hexagon. Yes, that's why these numbers are also known as hexagonal numbers. Now, how we can see this series 1, 7, 19? What's the relation here? As the name is hexagonal, hex means 6. So something we will do with 6. Yes, you will simply add the multiple of 6. First 6, then 12, you are adding the table of 6, then 18, and then 24, and then 30. But here they are saying write the next number. So what is the next number? If you will add 37 with 24, what you will get? You'll get 61. And after that 91. But we have to just write the next number. So next will be 61. We have to draw that also. How we'll draw that? Just see carefully. Here, what's the sequence? If you will see carefully, it's second step. So we are starting with 2, then 3, then 2. If it's a third step, we are adding with 3, then 4, 5, then 4, then 3. So basically what we are doing, if step is 1, 2, 3, 5 steps, so we'll start with 5. 1, 2, 3, 4, 5. Now what you have to do, you have to increase the number till fifth step. That means 1, 2, 3, 4, 5, 6. Then 7, 1, 2, 3, 4, 5, 6, 7. But we have to do till 5 step. 1, 2, 3, 4, 5, 6, 7, 8. One more step. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you have to stop. This is a center line. So there should be 4 lines above the center line and 4 lines below the center line. So now we'll reduce. This was 5, 6, 7, 8, 9. Now we'll draw 8. 1, 2, 3, 4, 5, 6, 7, 8. Now 7. 1, 2, 3, 4, 5, 6, 7. Now 6. 1, 2, 3, 4, 5, 6. We have to stop at 5. It's fifth step. 1, 2, 3, 4, 5. 8, 7, 6, and 5. And now if you'll see the last figure, it will give you hexagon. Now let's move to last question of this figure it out. Question number 5. Can you think of pictorial ways to visualize the sequence of powers of 2 and powers of 3? Here is one possible way of thinking about powers of 2. So we know that in powers of 2 we are simply multiplying every number by 2 to get the next number. So here we are doing the same thing. First we have one dot and now we are repeating that. Then we have two dots and we are repeating that. Then we have four dots, this four black dots, and then we have repeated that four blue dots, and then we have eight black dots, and we have repeated that eight blue dots. So now we have to do the representation of powers of 2 and 3. So let's do that. First we'll do powers of 2. It's 1. Now we have to repeat that. So let's repeat that vertically. It's 2. Then we have to again repeat that. So I will repeat like this. It's 4. Now we have to repeat these 4 dots. So I will do that vertically. This is 4 dots. I will repeat that now. Again 4. So this is 8. Now if you want to repeat this, I will tell you one more step. We have 8 dots like this. So we'll repeat like this. These 8 dots again. So it's 16. And then you can say so on. Now this is powers of 2. Let's do for powers of 3. So for powers of 3, whatever you will draw, you have to repeat that 3 times. So this is first 1. Now I will repeat this 3 times. So it will look like triangle. If I want to just give any visual representation. Now I will repeat these 3 dots 3 times. So I will do in such a way so that it will look like triangle. 3 and then 3. Yes, 3 into 3 is 9. Now let's do one more step, 27. So now I will repeat this particular design 3 times. So let's draw that first. This is one design. I have to repeat this 3 times. Now here. Yes, it's 27. And if you will repeat this design again 3 times, you will get 81 and so on. So I think now you know the meaning of powers of 2 and powers of 3. Basically, in powers of 2, you have to double everything, and in powers of 3, you have to triple everything. So that's all for today. We will continue this chapter in the next video. So stay tuned and keep learning with me. If you enjoyed this video and found it helpful, don't forget to like, share, and subscribe to my channel Mathify with Benakshi. Thank you everyone for watching. See you in the next class.